It's a true pleasure for us to introduce our next speaker. We almost see him already as a friend, having met only yesterday in real life, but it's a kind of wonderful story behind this because at the MARSEC-XL Council and in the MARSA committee, we were saying that one of our dreams is to actually get in contact with the people that set the standards. Now, with modern life and Google search and Skype and other things, we didn't really need to contact them because they found us. Fred Pott is working in marine management consulting out of Seattle. He's a senior advisor to the IMO and their e-navigation group. He's been involved in devices that, actually the foundation devices that many professional mariners know, maybe the AIS, and is here now to talk about e-navigation and the infrastructure needed to make this happen. So, Fred.
Thank you. To start with, thank you very much for inviting me. I mean, this was quite an honor to be invited here. And it's wonderful to replace Seattle weather with Malta weather for a while. My wife is really enjoying it. The accent you hear is Dutch. I live in the United States. I've lived there for 35 years, but my accent won't go away. So it will be in my Dutch version of the American language, if you don't mind. Let me bore you, first of all, with a few disclaimers. I do not speak for the IMO. I sure wish I had the power to do that, but I'm an independent consultant, and I'm lobbying representatives of the 60+ countries that make up the IMO member states, as well as some 90 international organizations like the IALA, the IHO, and organizations like that. I'm lobbying them and these organizations because they are driving the development of something called e-navigation. I'll go into navigation a little bit later, but you should not take the word driving too seriously. They've been driving to get e-navigation for about 5 years, and it goes rather slowly. We finally more or less have achieved working consensus about all of these entities about what problems e-navigation is supposed to resolve. But we're nowhere near to consensus on how to resolve those, and even less so on the infrastructure that's required to deliver these solutions. I feel qualified to talk about e-navigation because I specialize in it, and I've also had the privilege of working as a consultant to the Norwegian Coastal Administration, and they are, amongst all the countries in the IMO, asked to run the correspondence group. They are chairing the correspondence group of these 60 countries and 19 organizations. So they have a leading role in that, and I had the privilege to work with them. IMO actually doesn't develop anything. What they do is they come up with standards. Standards that ships and shore-based entities will have to comply with. And even those standards, they don't do on their own. They rely on organizations like the Electrotechnical Commission, the International Electrotechnical Commission, to come up with the technical formulation of what the standards. The IEC is, of course, another UN-type organization. Just a little bit about a typical merchant ship. Lots and lots of systems. There actually are more systems on board of this ship than this slide shows for the labels. And many of them, almost all of them, involve some kind of processor and proprietary software that runs on that software, on that processor. This is what you will find on a modern ship. This is Royal Caribbean. They use Sperry. What you see is lots of systems and controls and many, many multifunctional screens. And all these toys are giving us a big problem. The problem is that the young cadets that are used to playing video games want to run the ship from the screen. We're having a hard time getting them to actually look out of the window and see what the situation really is. These screens that you just saw, they can help, are multifunctional, and they can help whoever runs the ship, whoever cons the ship, in doing a number of different tasks. I mean, there are collision avoidance tasks, there's route monitoring, mooring, alert management, and systems monitoring are just some of them that are required to be done. And there are applications available, the red boxes on there, the applications can be brought up on the screen to help them do every one of those tasks, decision support applications. And these applications, they rely on a number of sensors. Some of them are on board, and some of them are not on board. Radar, the GPS, wind meters, the log speed, the water speed, the depth sounder, the gyro are all on board. And many of them, of course, are duplicated for redundancy purposes. And then you have the remote sensors. I don't know if you know about the AIS system, the automatic identification system, but that's basically a system where ships send out who they are, where they're going every few seconds. And you can receive that and display it on your screen. And then there are a number of other remote sensors that can be used. But that really requires e-navigation to do that. We really don't have anything beyond AIS yet that can be used. Let's talk about e-navigation a little bit. I'll give you just a very high-level overview. It gets very complicated, but this is an overview that kind of tells the story. We have a shipboard user that uses an application that's based on data, and there is a management information system that guards those data, that manages the data. And what we need to do is we need to start to have information exchanges with shore-based organizations like the Green, the vessel traffic, or with the search and rescue people, so that we get on board information that vessel traffic has that we do not have on board, and the search and rescue gets stuff from the ship that they don't have shoreside. These information exchanges are called services. The correspondence group in charge of the development of navigation calls these services. And of course, the detailed specifications of these services have yet to be determined. But we know that an overarching communications and information infrastructure will be required. But like the services they will deliver, the navigation infrastructure requirements have yet to be determined. Now, in this talk, I will examine aspects that the correspondence group may want to consider in the design of the computing environment, especially the onboard computing environment. And I'll try to make the case for an open reference systems architecture that allows standardization of these services. So these services need to run on any ship. To significantly reduce the cost of the required computing environment on each ship, and at the same time making it secure, robust, future-proof, and able to take advantage of industry innovation. Let me talk about some more detail on some of the services that are being considered. The mariner spends an awful lot of time doing administrative stuff. It takes time away from actually running the ship and making safe decisions. They spend an awful lot of time updating documents, nautical publications, and the ENCs. Now, it used to be paper charts, and updating a paper chart was even worse. But at least now we are going, by 2018, we'll have a mandate out there that everybody needs to use an ECDIS, an electronic chart and display information system. So that updating of the chart becomes a little bit easier, but still, it's a lot of work to keep track of which versions and the encryption and do I have the latest version? Don't I? And that's true for not just the electronic database that runs the chart system, but also for all the other applications that they need, the pilots, the BTS guides, everything else that they need. There's a lot of work involved in that. And so what e-navigation is supposed to do is to automate and streamline updating of electronic charts and documents, and also streamline ship reporting to port and coastal authorities. Let me talk about a ship that goes from, say, Helsinki to the Suez Canal. It needs to report, not only to report a destination, who it is, what it has on board, all the security information, passports of the crew, everything else, and the cargo on board. But even when it passes through the coastal areas of all the countries in between, there the environmental protection people want to know what's going on. The security people want to know what's going on. So we end up spending an awful lot of time reporting to all of these authorities, and every authority, of course, has its own forms, and its own fields, and its own way of doing it. The other thing that we want to use e-navigation for is to provide ships and shoreside users with additional information that they currently don't have. So on a ship, we really don't know much about what the currents are, what the water level is, the traffic flow plan, what accidents are around, the weather is, and things like that. From the ships, the VTS, the Vessel Traffic Service, they want to know, what is the course speed, position, the status, and also what is the accuracy of your instruments. So you're basing your calling decisions, your decision on how to steer a ship on a set of instruments, and they want to know, well, how accurate are the instruments that you have on board? What version of the chart do you have? Is your GPS working well? Does it have a good position fix? Also, rescue coordination centers. When there's a calamity going on, there's a rescue coordination center involved, and they need to know everything what's going on the ship. So they want to know a lot of detail about what's happening on the ship. And it's more than just where the ship is and where the speed is. Speed also is 0. But what's going on with the tanks, which compartments have been flooded, and all these other sensors that are on board. And they want to be able to share that information with the other stakeholders that are involved, people that are helping out there to resources that are out there to help resolve the situation. Another example is when a ship comes to a port, there is a vessel traffic service normally, and there are very many different ways of doing vessel traffic service. Some ports, Rotterdam has lots and lots of things available that you can use, and other ports have less, but mariners have no knowledge really of what is currently available. Yes, there are VTS guides, but what's really available are not running right now. So a portfolio of services would be something very useful to have. Let me talk about the infrastructure. Now, these are the aspects of the infrastructure I'd like to discuss, and I won't go through all of them in detail for this slide, but we'll touch on some of them in the rest of this presentation. Just first of all, security. It's kind of apple pie motherhood. You need security. Some of the information that will be exchanged, sent to shoreside authorities about the crew, about the cargo, is quite sensitive. So we probably will need some kind of secure method to convey that information. It may be even have to be encrypted. So designers of the infrastructure may want to consider public key cryptography based on systems such as TLS. Redundancy is another thing, motherhood and apple pie. We need to have it. Delivery of e-navigation services should be insulated from failure of a single function of the infrastructure. So what the correspondence rule needs to require is that all critical resources have a hot standby with automatic failover. Ship-to-shore communications. Let me talk about that a little bit. We want to do these information exchanges, but not likely are we going to design a whole new communications network, worldwide coverage, to do that. We're going to have to use whatever networks are available right now. And here's a list of the things that are available right now that are being used. GMDSS is basically the distress system, and it has 3 components. One is based on Inmarsat-C, that's a very low speed satellite communication system. NAVTEX is a telex over radio system, very slow. DSC, digital selective calling, can be used on VHF and HF. You can communicate data with it, again, very slow. AIS, I talked about AIS a little bit already. 19.2 kilobits per second is the maximum you can reach with it. And there are areas where we already tick blocks with just the general information that ships send out about who they are and where they're going, where you can't lay on top of that other traffic. So that's a limitation. And there are other things that are better suited, I think. TCP/IP based communication channels, satellite, and in satellite, of course, you have the various. You have Inmarsat, you have VSAT, you have Iridium, you have others. Cellular is coming up as a very good alternative when you're approaching ports, very high capacity. Wi-Fi when you're in port, possibly mobile WiMAX. Actually, that is being used in Singapore. The state of Malacca is the busiest waterway in the world, and they are leaning towards starting to use the WiMAX. They've done some tests there. And there are other communication networks that you want to use that haven't even been invented yet. All of these networks have widely varying coverage, speed, latency, and cost. And some of them use non-TCP/IP protocols. So the ones in red, they don't use TCP/IP. But if you look at what information needs to be transferred, it's not all high priority. Some of them will require high speed, low latency, usually for smaller amounts of data, such as the shore-based sensors. That you're going to get that information on the ship as soon as possible. But other services can live with lower speeds. Updates of VNCs, you can wait a while to get an update. You can trickle the information down at lower speeds, at higher latency, and less priority. Another thing we will need, and that's a real problem right now, the crew spends a lot of time running communications, and we need to automate that. We really do need to come up with an e-navigation communication network router. You need to be able to select what network you use, given the current coverage, what the message size of the priority is, the cost, and the level of congestion. And what is going to be needed is that some of those networks are non-TCP/IP, so the communications network router will need to do the translation between whatever network you use and TCP/IP. The format that's going to be used for transmissions is going to be the S100 GIS format. It's an ISO standard, the 19100 GIS standard, adapted to the maritime field. It includes not only values, but also other metadata, such as how do you show that a collision has happened in a particular place? How do you put it on the screen of the navigator? It's based on the XML schema, and for the features and the other attributes that are involved in whatever piece of information you're trying to display. But XML is notoriously verbose and inefficient. So transmitting geospatial S100 information will require high bandwidth, and that's not always available. So if you want to use those slow speed connections that are available basically for free, safety net, Navtex, DSC, AIS, you're going to have to come up with some way of compressing the data or periodically retransmitting the static data as we do in AIS. We probably need to have a network address register that ships and the shoreside, everybody who participates in the e-navigation information exchanges have an entry in a network address register. And the entry is something that they advertise on each network. And that tells them, that tells the world in their particular section of the world who they are and how they can be reached. It should include things like the call sign, the Mobile Maritime Service Identifier, MMSI number, the email address, the IP address, phone numbers, satellite and cell, and currently available networks, their speed latency, their cost, and the level of congestion. And for remote inspection of equipment and for these search and rescue purposes, you will not only have to do that for the whole ship, you'll have to do that for individual sensors on board of the ship. So that SARC people can get detailed information, and BTS can get detailed information on the health of your equipment. The recommendation is to require that network address advertisements are collected and kept up to date in a remote network address register that can be accessed only by authorized entities to keep their local address register up to date. Information management. Again, this goes back to what I talked about earlier. Electronic navigation charts and their updates, nautical publications, software updates of the embedded systems, and then also the reverse, voyage and ship sensor information to shore-based users. The way to do this is to use a modern pub-sub model to publish and subscribe the data. The information management system would manage the subscriptions, and in the case of an electronic chart, for instance, the publisher of the chart advertises that I have a new update, and the information management system makes sure that you have the latest one available. So it gets it and publishes it, and makes it automatically available on board as a searchable document or even a working database, like in the case of an ENC. Upgrading of service applications. We're going to have a lot of service application apps, home apps, that need to be updated from time to time, that are running on your own hardware, on your own environment. They need to be updated. IMS needs to manage that also with subscriptions. And then even the updating of embedded system software should happen with the IMS, with some manual input. IMS should also work the other way, as I said. It should also collect information from the ship and publish it and make it available to shoreside users to provide port and postal authorities with ship reports, for instance. A subscription needs to have, at the application level, a lot of details. It needs details such as how is the security handled, the encryption handled, what are the financial transactions involved, expiration dates of the subscription, the preferred communication, and the maximum latency. For every subscription, you need to have this kind of information. And not just for ENCs and that kind of data, but for all the services. And even if they don't involve a financial transaction, and even if the source of the data is the ship rather than the shore. So what does IMS need to do? What is the functionality that's required? Well, it needs to have subscription lifecycle tools. You need to be able to set up and update subscriptions. You need to be able to publish searchable documents as operational database in the private cloud that's accessible to authorized users both on board and remote, and allow manual control of embedded software upgrades. Let me talk a little bit about the reporting to shoreside authorities. I talked about it earlier. This is where I'm recommending that a community cloud is set up that ships will use to host a virtual presence on. And on this presence has a website, has the static information, the name of the ship, how big it is, things like that, the voyage information, from where to where the cargo is, who's on board, and the dynamic information, the positions. And it tells that, publishes that, and you see with the various shoreside authorities, vessel traffic control, search and rescue, security, environmental protection, take out subscriptions to that information. Whether it's Atom or RSS, I don't know. Jim, you don't have time to that one. That's not how it's done right now. And there's quite a bit of resistance against it, although the IMO is working on some standard forms. The IMO is working on file forms that would standardize the reporting. Where do you run this community cloud? Well, the Maritime community has set up data centers for a system that they call the long-range identification and tracking system. It's one of those things that the IMO decided that they needed to do, It's AIS for the long distance, and it uses satellite. They finally came up with a specification for it, and they finally implemented it, and now they have data centers running around, and it's out of date. It doesn't work anymore. Yes, it works, but it's so slow and it doesn't give enough information. So reuse the data centers that were set up for LRIT to host this community cloud. The onboard infrastructure will need to host several applications. I already talked about the communications router, the security key manager, network address register, the information management system, and other service applications. And we need to be able to run that on whatever is available on the ship. So we need to have some middleware that uses the hardware that's already on the ship, the computing environment. And the computing environment, my definition of it is whatever the server hardware, the local area network, the operating system, and database management and hardware and software. You need to be able to use whatever is on board already. And because it changes from ship to ship, you need to use middleware that allows standard-based e-navigation application to run on any ship. The middleware should provide a common platform that is independent from the ship's computing environment and thus allows standardized and certified e-navigation service applications to run on any ship. I know I'm repeating myself, but I think that's very important. Platform as a service is, to me, the answer. Platform as a service, I did some research on how to define that, and this is a picture that I came up with that seems to show what is and what is not included in platform as a service. It would be a cloud hosted on the ship's hardware that includes all the layers up to the top of that arrow that shows platform as a service. So it includes the data center, mechanical and electrical. It includes the networking environment and the firewalling. It includes the physical servers. It includes a virtualization layer, I'll talk about that a little bit later, the operating system, and infrastructure services such as the database and other things. So that would be the responsibility of the ship to provide that and provide a standard version. The publisher of the e-navigation service applications will be responsible for the applications themselves. And they need to be able to run on any of the PaaS clouds that are available on these ships. Just as a demonstration or a further explanation here, we have two ships, A and B. One of them runs Windows, uses a Microsoft SQL database on a Dell hardware, and they run Windows applications, email, human resources, payroll, timekeeping, the store's inventory and purchasing, maintenance planning, inspection planning, online forms, etc. The ship B has exactly the same application, but they are a Unix application because they run HPUX on an HP hardware and use an Oracle database. Now what we need to have is to keep running those same applications on those ships, but share the hardware and set up a PaaS cloud that allows these standard e-navigation service applications to run. And the e-navigation service application should not interfere at all with the ones that are already running on the ship. The PaaS cloud standard. I am lobbying for adoption of MARSA as the standard for the e-navigation PaaS cloud, because it's a reference architecture for the layers that make a PaaS, but it doesn't force ships into using specific solutions for each layer. It's technology neutral. Zach Borg developed MARSA and later contributed it to the open source community. And that means that anybody can use it at no charge. And that there's a community of developers that continue to improve MARSA, much like the open source Linux software. It was initially developed for recreational vessels, but the MARSA community is currently extending it, as I understand, to offshore support vessels. MARSA already complies with that Norms Veritas, that's a classification rules and guidelines for the software and for integrated computer systems. These rules require, amongst others, that you need to avoid any single point of failure through redundancy and independency. An instance of MARSEC, of the MARSEC reference architecture, can coexist on a ship's computing environment. For instance, a Microsoft Windows environment, by introducing a hypervisor. A hypervisor layer that coordinates the use of resources like the CPU and the memory, the hardware resources, between the two systems. That's what this picture is showing you. The specific technology solution that populates each layer of the MARSEC reference architecture can be open source, but it can be proprietary too. But it needs to certify and comply with the MARSEC standard, and that's where the whole organization or governance comes into play. Designers of the e-navigation infrastructure, that's the correspondence group that I'm talking to, should consider mandating that all ships carry an instance of the MARSEC reference system architecture on the already available onboard IT hardware, or start carrying hardware. Not all of them do. The reasons to do that is that MARSEC fulfills almost all of the infrastructure requirements, and it reduces the cost of the setting up infrastructure on board significantly, and it makes it secure, robust, future-proof, and able to take advantage of future innovation, industry innovation. The designers of this e-navigation infrastructure may want to join the community, the MARSEC community, to assist and possibly even lead extending MARSEC to cover e-navigation needs of the commercial marine industry. Now, I'd like to go back to these two slides. Remember them? All the sensors and systems that are on the ship? As I said, almost every one of them involves a CPU of some kind, and many of them use an embedded CPU like an ARM. E-navigation standard service applications need to be developed and implemented without having to customize each application for each ship's particular equipment portfolio. So, an integrated navigation system, INS application, should not need to know what depth sonders the ship carries, which one is the primary, which one is the backup, where on the ship it is located, and what the accuracy and health of the depth sonder is. All this information, metadata, should be encapsulated in an information service that the INS application can subscribe to. There are some issues with what we have right now. Most of the sensors and electronic instruments are connected to other systems via a proprietary network. But even if in a standard like IEC 61162, which is the EMEA standard, if that is used, the bandwidth is limited, and only a limited set of messages is available. So things like health of the system is simply not available, not yet anyway. It's typically very difficult, almost impossible, to use the information that the electronic equipment generates on a non-proprietary secure network for conveying sensor values, assessing the health of the equipment, remote troubleshooting, and I'm talking about remote troubleshooting here, like really remote, meaning that if something goes wrong, you can call the whole office, and rather than having to fly somebody to the next port where the ship comes in to go see what's going on, be able to do that right from the office of the shipping company, or even from the supplier of that particular piece of equipment. And then also to remotely upgrade the equipment's proprietary embedded software at an opportune time. To get there means a sea change for providers of electronic equipment. And what I'm lobbying for is that 3 levels of performance standards are developed. That they should be given, that the vendors of this equipment should be given a choice, several choices in making their equipment compliant. The first choice is depicted here, but you have the MARSEC cloud on board, then you have the instrument, the electronic equipment, that runs its own CPU with its own operating system and its own software, but there is communication going on with it that already exists, either it's proprietary or it's NMEA. And the only changes that vendors will have to make is that they need to write an equipment service plugin that can run on the MARSEC cloud and that can listen to whatever the equipment generates or have two-way communication. And add things like the health, and add things like the ability to update the software, to upgrade the software. The health, by the way, a built-in integrity test that runs automatically on the equipment to tell you whether everything is okay, and the test results need to be communicated. The second option that should be given to the equipment providers, a performance standard setup to allow them to run the equipment resource services right from a MARSEC cloud on the own equipment. So you run an instance of MARSEC on the electronic equipment. And there are many cases where that's possible already. It may require some big upgrade of memory and CPU speed, but it's not a wholesale change, but you still have your own operating system there with your own proprietary equipment software, but you do introduce a hypervisor. And the thing that you achieve by doing this is that you're getting away from this proprietary communications or NMEA communications. You use the peer-to-peer communication between instances of MARSEC to exchange information. This is the ideal. Now we have a MARSEC cloud on the ship and a MARSEC cloud on the equipment. And guess what? Now the proprietary software also runs on the MARSEC cloud. I think you still need an equipment service, resource service there. There are hardware pieces that you need to deal with. But you could run the proprietary equipment software on that cloud, but you could also run it on another cloud. Meaning that you can achieve redundancy a lot easier without having to have the cost of completely having a second depth sounder there, or a second radar, or a second whatever. If you do that, then you take advantage of all the features that MARSEC brings: access security, redundancy. You minimize the cost of the equipment. You can run a pedometer or a depth sounder as an information service on a cluster of MARSEC-enabled computers, moving away from the one box per function syndrome that is currently prevailing. And you can expect to drive down costs to the point that even the smaller ships can install quite sophisticated onboard systems. My last slide. E-navigation services will require an overarching infrastructure and an onboard infrastructure. The success of e-navigation will, to a large extent, depend on the architecture of these infrastructures. MARSEC is incomplete, but it would provide a reference architecture that will allow e-navigation to use the already existing but disparate hardware to be unified in a future-proof onboard computing environment that in turn will allow all yet to be defined e-navigation service applications to run on any ship. And the last part of the conclusion was already talked about here, that the US Navy reports that the cost of total cost of ownership by using open architecture and using common off-the-shelf components, you can reduce costs up to 80%. And if the commercial maritime industry implements that MARSEC system architecture, it should expect to have similar cost savings while future-proofing its systems. Thank you.
Thank you very much for that. Would you be ready to take some questions from the audience?
I think I can talk about that. All right. So, okay, makes sense. Fred, one of the themes you talked about several times was the low bandwidth, slow communication networks, and I assume that's mostly between the ship and other entities. I'm ignorant in this area, but I just wonder, is that always going to be the case, or is there any technology underway that might allow for faster communication between the ship and others?
On board, there are a lot of different systems and a lot of things going on. And shipping companies are finding that they need more bandwidth. And they're willing to pay for more bandwidth to satellite companies to do all the things that they need to do and integrate whatever happens on the ship with the systems that they have running shoreside. That really is the driving force behind companies going for VSAT right now. There's a huge drive towards VSAT because it has a big bandwidth and it's not all that expensive. So e-navigation can take advantage of that, and we will be bandwidth will become more available. But still, you have to pay for it. And when an international organization like IOOI says you will transmit this and you will receive that, immediately the shipping community says, okay, and who's going to pay for that? Long-range identification and tracking is an instance of that, where the shipping company said, well, I need to go use my satellite connection to give you this data. You better pay for it. And they spent years figuring out the pricing scheme and how to be reimbursed. I hope that we're not going that way with e-navigation. And one of the ways to avoid that is maybe some of this stuff, small pieces of data, can be sent over these traditional legacy networks, which basically are. So yes, there is strong development towards more bandwidth, TCRP bandwidth, but there still always will be a need for the no-cost, low-speed bandwidth.
Thank you. Any other questions, please?
Hello, yeah. So as we are moving towards open source and we are proposing an open source architecture in MARSEC, don't you feel that it will create a single point of failure for such sensitive and important applications like e-navigation, and at the same time customers will not have much choice? So if something goes wrong with one thing, they won't be able to get better customer support and other choices to go for.
I need to ask you to clarify. Are you asking, is there enough computing power available on board to be able to run MARSEC alongside other applications?
Not really. What I'm asking is, if we have open architecture, like the one MARSEC recommended, will it not create a problem at customer end? Like they want to be able to get much customer support, and at the same time, there might be a single point of failure. If there is something wrong with that architecture, they won't have any other choice.
I must admit I have trouble understanding what you're asking, but I think what you're asking is the level of support that people can get for open software.
Yeah.
And I think there are lots of examples of how that is done in the non-maritime world. And I would point to Red Hat as a very good model, where Red Hat is taking open source software and assisting companies to use it, and allowing them and supporting them in the deployment and the maintenance of an open source environment. Those kinds of opportunities are around, and I'm sure that Red Hat is ready to jump in with sub-services like that for the maritime community, and I'm sure others are as well.
So, what you are suggesting is we will have open source architecture, but we will have separate companies which are providing customer support on payment.
Yeah.
That's not free. That's not.
No, that won't be free. No. You will have to pay for that support.
Jim, perhaps you would like to comment a little bit on that. Would you like to?
As I understood the question, it was if you are depending on open source solutions, what kind of support do you get for it? Is there support for it? And history has shown that there's a wider selection of different kinds of support available. There is the commercial support that Fred was talking about that you get from Red Hat and things like that. Also, because all this stuff is done in the open, if you're intelligent enough or savvy enough or have enough time, you could get your own support by interfacing with the community itself. You know, if it's not something that's critical, you could go online and go to mailing lists and ask questions and things like that. So there's a wider variety of support offerings to you in an open source environment than there is in a commercial proprietary environment.
Thank you. Any more questions, please?
I have a final question for you, Fred. We, of course, were delighted with your presentation and your suggestions and your recommendations. So, and your wish list for where MARSA is incomplete, which is absolutely correct. MARSA will probably never be totally complete because it's a moving target and it's a community effort. So basically, what we will do is we will host your wish list as a challenge in the community and see who can help us develop it. With respect to that, will IMO correspondence group ever get involved in actually contributing to the involvement of the MARSA, or do you expect companies and standardization organizations, maybe class societies to be contributors? What are your thoughts on that? The IMO itself will not really directly contribute, they will more set the direction, right?
Yeah. Again, IMO doesn't develop anything. All they do is come up with standard, and then they vote among the countries and say, well, you all will adopt these standards. You all will adopt the standard. What an electronic chart and display information system will and will not do. They have a performance standard that was adopted and will go into effect for all ships by 2018. The infrastructure standards will be something like that. But if you look at the standard for ECDIS, where that came from, it's a standard that was developed by the International Electrotechnical Committee, IEC, the Technical Committee 80, and part of the work groups there, AIS, but they typically set up a work group. Now, in that work group, you get experts from various different countries, and they contribute and they generate a proposed standard, which then later on typically is rubber stamped by IMO, and that becomes the standard. But the experts that are in those work groups are the ones that can be expected to participate. I do expect that once it becomes clear that vendors will have to comply with this open standard, that all at once they will find money to start to contribute to it, to learn what's going on, and try to get a leg up on their competitors. So yes, IMO itself, no. The correspondence group, no. IEC, yes. But those committees have not been formed.
Just a final question then, just to make it clear, probably kind of answer that question, but within the current correspondence group on the navigation, is there, or ongoing related projects as you know, is there currently a dedicated work package or group working on architecture?
Again, only at the level of the correspondence group is there a strategic implementation plan, and the deadline for that is 2014. I doubt that they can meet that, but there is an awful lot of detail that needs to be worked out by other organizations that the correspondence group will not do itself. And those work packages have not been defined. And that's one of the things we need to do is to be involved in the definition of those work packages, because defining what these work groups will work on sets the path.
Thank you very much. Okay, now we're having so we're having a coffee break. We strongly recommend some fresh air and maybe even sunshine out there. During the break, the MARSA core team will roll their current presentation on the screen, so if you want to see what's going on, you can have a sneak peek on that. And we're back in about 15 minutes.
So whilst enjoying your refreshments, please have a sneak peek on Mars.